So today's webinar is basically on the topic additive manufacturing, or we can say it's an introduction on additive manufacturing. So what basically an additive manufacturing is in this PowerPoint example, we will be able to understand and what are the types and how basically we will be what one second, one second. Okay, I'm starting it again. So sorry for interruption. There is a mic glitch. Yeah, so I was talking about the that in this webinar we will be able to understand what is additive manufacturing and how we can perform, what are the steps we can make an object, how can we make a model, and what are the various types of process in additive manufacturing, what are the applications. These are the things which we will be covering in this webinar. So let's get started. So the first is the introduction of rapid prototyping. So what does basically it means? So it refers to the process which is used to quickly create or represent a system or a part before it's finalized or commercialized. So we can think in this way that suppose we have an idea which has been generated or a design we have before there is any mass production. So it is a kind of that only. So since according to the American Society of Testing and Material ASTM committee, they have basically what they do. They have used the name instead of rapid prototyping. They have changed the name to additive manufacturing. So the core idea behind additive manufacturing is that we can what you can do we can use 3D models, typically created using softwares called computer-aided design software. We can use it like SolidWorks, CATIA, etc. Then instead of we go for a traditional manufacturing process, which required certain plannings and all things. We use additive manufacturing, which allow us to fabricate the model directly and precisely. So a prototype basically is essentially, we can say that it's a first or an original version of something that serve as a model, or you can say a preliminary version for any further development. So an example that there is a we have a suppose we have made a prototype of supersonic aircraft. So the first supersonic aircraft what we have as a model for the future copies or development in the aircraft design. So this is how what a prototype does. Basically, it is a first and original version we can say of anything. So we before going to that, we should understand the fundamentals of prototypes. That what is basically what we do in prototypes. So there are three main aspects which we have to consider. The first is the implementation, forms, and degree of approximation. So in implementation, basically, what we do, we refer to how the our prototype is realized, or we can say in the real life, how will it exist. So it could involve entire products also, or it can be a subassembly, or even it can be an individual component. and it is about how the product is put together and made function. So this is the part in implementation of the prototype, that what is basically how we try to make the like brought into existence, how we make a prototype. So first is implementation, second is the in form. Basically what we do, prototype uh, basically a various form, like ranging from virtual to the physical representation. So in virtual, a prototype which is basically exists digitally, often use computer generated models. And if we go for the physical prototype, which is is that we can touch or we can interact with them. So that is the physical prototype. So both virtual and physical like prototypes serve the purpose. Basically, we use for testing and validating the ideas of our design. And third is the degree of approximation. So in this aspects, basically we relates to how closely the prototype matches to our final product or design. So a prototype could be a very rough representation, we can say, capture only the features and functions, or it could be exact replication of the product, providing a new, we can say, perfect review of our final outcomes. So this is what about the prototype is. So now comes to we can see what is additive manufacturing. So additive manufacturing is basically a cutting edge fabricated process which is used to create a three-dimensional object directly from 3D like CAD software data. Unlike we are using a traditional manufacturing method that basically rely on the part specific tool like mold or dies, AM, or we can, it is abbreviated as additive manufacturing basically is abbreviated as AM also. So AM basically build object layer by layer using automatic techniques. And originally it is also known as 3D printing, and it has evolved into a broader term encompassing a range of technologies that shares the common principle of like layer based fabrications. So, if we see, if we take an example to understand it, we can think like that. Suppose if we are building some stack layer by layer of a material at the top of each other, then we must say that the building of this stack layer by layer will produce some solid after the layer is completed. After the layer by layer, this stack is completed. So that is the additive manufacturing. It makes layer by layer, it is processed layer by layer to make a final product. So from here, it is I have taken an example of a cup. So additive. So from here, we will be able to understand that additive manufacturing, which was also referred as 3D printing, or we can say rapid prototyping also. It is a method of creating objects by layer material based on 3D model data. So from traditional concepts manufacturing process, we are using subtractive method like machining, which involves cutting away the material from the solid blocks. So additive manufacturing is not a subtractive method; it is an additive method, because in this we build a layer by layer, uh, layer by layer, like the material we are building it. So since in this example we see that there is a teacup which has been manufactured with the help of additive manufacturing. So if we see the second part, the fine layer thickness, the layer thickness is very fine, which each line is thin. So the cup surface will be like here it's represented as smoother and more refined compared to the other one, which have little bit larger thickness. And this is because finer layer allow the greater detail and precision in the fabrication process. So the quality of the final layer is much more higher than the layer whose which is not much finer. So, and also the choice of this layer thickness is in additive manufacturing significantly impact the final appearance and the quality of the object which has been produced. So additive manufacturing also name from other names also. Like in additive, we can say additive manufacturing, additive layer manufacturing, additive digital manufacturing. These all are the common names which are used different by different persons, different books, but meaning says same. Layer based manufacturing system, layer oriented manufacturing system, layer manufacturing, these all are additive manufacturing parts only. Rapid technology, rapid prototyping, rapid tooling, and even digital fabrication, these all, and 3D printers. Nowadays 3D printers are used more compared to this additive manufacturing. So the first thing is, what is the difference between like this additive manufacturing and traditional manufacturing like CNC machines while we are using. So in CNC machine, basically what it is a kind of subtractive manufacturing process. So in this, what happened? It start with a solid block of material, which is kind of metal or plastic, and these from this block material is been removed using a cutting tool to shape the final objects. So essentially, what it do? It craves away the unwanted material until the desired shape is achieved. So this is what a subtractive method which is being used by a traditional manufacturing like CNC manufacturing. But in additive manufacturing, basically we are using an additive process. It builds an object layer by layer, adding material only where it is needed according to the digital design, and which eliminates the need of like material removal and allow for the more efficient use of resources. So uh, this is the basic difference between the additive manufacturing and the CNC or traditional manufacturing. And in term, if we see in terms of waste also, CNC machines generate significant material waste because it starts with a large block of material and cut away excess to create the final shape. This can result to the higher material cost and environmental impact due to the waste disposal. On the other hand, if we see in additive manufacturing, the material, the waste material basically is very much minimum, since it have only the material necessary to build the object, and this reduce the cost as well and contribute to the sustainable by minimizing the waste generation. So, if we differentiate in terms of material, speed, and ease of use, accuracy, size. If we differentiate this traditional and modern like additive manufacturing in terms of this, so if in terms of material, if we differentiate, then additive manufacturing basically use can be used for the wider range of material like plastics, metals, ceramics, and composites. It can accommodate material with diverse properties and characteristics. But on the other hand, in CNC, or we can say conventional material like metals, aluminiums, steel, etc., plastics, and woods, it is also versatile, but comparative to additive manufacturing, the range of the material is less. And if we distinguish in terms of speed, then additive manufacturing process are generally slower. Like here, like the additive manufacturing has a drawback that it production is little bit slower to the CNC machine, especially for the large and the complex part. And each layer deposition time with the add-ups, which increase the like timing of the product. And on the other hand, if we go for the CNC machine, so CNC machine is much more faster, especially for the high volume production run, and also for the symmetric geometry also. And it quickly removes the material using various cutting tools, which results in overall production time, faster overall production time. And if we distinguish ease of use, so additive manufacturing is much more easier to set up and operate, particularly for the for the beginners who just started using additive manufacturing, and we do not need any like extensive machining experience also. And even also it requires minimum machining tooling and fixing, which make it more accessible for prototyping and small scale production. But in CNC, we need a required skilled labor. And here setup time is also large comparative to the additive
Very time.
manufacturing. And
Correct,
in
Pratik.
terms of accuracy, size limitation, and geometry complexity, if we distinguish it, so additive manufacturing excels in produce high complex geometry with integrate internal features and organic shapes. However, it may have some limitations like dimension accuracy and surface finish for the large part. For the small part, it is very much accurate. But on the other hand, if we'll go for the CNC machine, the dimensional accuracy and surface finish is very much excellent, and which make it precise, and precise for the product is very much precise and with high tolerance. Good. And even in CNC, we can handle large parts or objects with high precision. And but complex geometry, we go for the complex geometry. In CNC also, we struggle comparative to the additive manufacturing. So, in terms of programming, if we understand, additive manufacturing typically requires less programming and setups compared to the CNC machining. And this process is basically is we can say largely automated with the CAD model directly translated to the machine instructions. So there is no much interface between that. But in CNC, basically we need an extensive programming for toolpath generation and for tool selection as well. So it requires specialized CAM, computer-aided manufacturing softwares and knowledge of some machine strategy, how we can make it, how we can set the tools in the CNC machine. So in terms of cost, we go for it. So additive manufacturing is cost effective for the low production and prototyping, and if we want to make any customized part, additive manufacturing is good for the low production volume. And if we go for the CNC machining, then it is cost effective for the medium to the high production volume, and especially a simple parts and geometries. But in CNC, initial setup cost is higher. But for if you go for the production point of view, it is economics compared to the additive manufacturing. And if we go and about the distinguish it according to the environmental condition, then additive manufacturing are more environmental friendly in terms of material usage, as it generate less waste compared to the subtractive method like CNC machine. However, it may be consume significant amount of energy, especially when we are using a metal in the additive manufacturing process. So this is a kind of distinguish between the additive manufacturing and CNC machines. So this is the process chain actually, that how basically we perform how we can make a part. There is a process. It consists of around 8 process to make a final product in a 3D printer, we can say. And so how we can follow this 8 process step by step to achieve what we want, or we can say to produce with the help of 3D printer what we have designed. So the steps are as follows: first we make a CAD in a various 3D CAD model. After that, we convert that CAD file into the file which is accepted by the various 3D printers, which is an STL file. And then this file, after conversion, what we'll do, we'll transfer it to the machine, and then we have to do the machine setup. We have to build, we have to remove if we have used some supports and all. Then post process, and after post process, we will get our final product. So here we will go. We will. These are the 8 steps we will be following to understand the product, what will be, how we will getting the product at the end after the creations or layer by layer creation of a product. So these are the process. So let's go for the step one. So in first step of additive manufacturing, basically it is a conceptualization, or we can say conceptualization and a computer aided step. So in this, we can say that we are creating a blueprint of an object which is to be manufactured. So and this is a initial phase also, which involves conceptualization, the design of an object which is to be produced. So the this could involve like brainstorming ideas and considering functional requirements and the final how the final product appearance and how will it function. So once suppose we have designed the concept, the next step is to translate it into the digital 3D model. And this digital 3D model we can translate with the help of using computer aided design software such as SolidWorks, yeah, and different software as well. So CAD software basically what it do, it provides powerful tooling for creating, or even we can manipulate and analyze geometric shapes and assemblies. And these tools basically help us to define the object in terms of dimensions, features, and the properties of a product. So there are basically three ways to create a 3D model. Like the first is computer generated model, the second is solid modeling system, the third is surface modeling. There, these are the the ways we can use to make our model. So with the help of computer generated model, the model basically generated entirely by the computer algorithm, which is predefined, or which is already present in the computer, like in the software. The model already, suppose we want to make a cube. So in CAD there is already a 3D there is already uh, predefined shape is there. So we just can import that predefined shape and we can use for the printing. So that is one of the type. The second is the solid modeling. So with the help of 3D CAD, we can utilize solid modeling technique where objects are represented as a solid volume, and which also have a well-defined boundaries and surface. In surface modeling also, we can use surface modeling CAD software also. So it is basically an additional to the solid modeling. In some CAD, basically we have to, in some model, basically we have to work on the surface also. Suppose we have to make a curved surface, or we have to make a enhanced or complicated surface. So we can use a surface modeling also software to make a model good. So these 3D CAD software basically works on a iterative, it act as an iterative design. Means what does it means? That we can visualize a model when we make with the help of this 3D model. And in suppose if we want to change some data, or we want to change the design, we can easily change it with the help of this software. So this software are very much flexible to to our design what we are making, which improve the we can optimize, which improve the optimized design and also improve the performance, manufacturability, and also with the help of this we can improve our cost also. So in second, after the first step is conceptualization, in which we make an idea that we have what we have to make. After that we convert this idea into a 3D with the help of CAD softwares. Now, after completing the design with the help of CAD software, now it's time to convert this file into some extension known as STL file. So this STL basically it is a standard tessellation language. So what basically in this we do this STL basically known as a stereolithography, and it is one of the earliest additive manufacturing technology. And this is very, we can say it is a file format which is used to describe the geometry of a CAD model without any uh, any construction data or modeling history. So it basically focus on representing the surface of the model through a series of interconnected triangular facets. So basic in this STL file, we used to see that our 3D model is being converted into a interconnected triangular geometry, which is on the surface. And after that, during this conversion process, the CAD software basically remove integrated any integrated like constructions data, or also it approximate the model surface with the triangular like geometry. So these geometry represent the surface of an object in a very simplified manner, allowing any efficient data that represent the suitable for additive manufacturing process. So most of the CAD softwares basically adjust the minimum size of this triangular facet to optimize the resolution and surface smoothness of the final printed object. So the objective is to ensure that the model created here is do not exhibit any obvious triangular surface on the triangular geometry on the surface, which lead to the visualize like accurate representation, so that when it is transferred to the like 3D printer, a very smooth and an accurate model is printed. After that, like the process of converting the CAD model into an STL file is basically in an automate model. Uh, when we use a CAD software like suppose SolidWorks, so when we save our model as a save as, there is an option. We can select that option that we have to save our model in an STL format. So it automatically like save that file into the format like STL format. So while with this complex geometry, it can be also challenging for us to detect the potential issues of if there is any like a problem in the geometry, or is the complex geometry is very if our means model is very complex, then what happens, the potential error what we find in the CAD model, or we can say in a STL data inspections, these error may be like what kind of error this may be like geometry inaccuracy, or we can go for we can see there is an topological error, or the mesh is also invalid or overlapping to each other. So these are some like the challenging issues which sometimes we face during the conversion. So some errors like in can maybe unnoticed until after the part has been built also. So these are errors would can lead to the defect or imperfections to the final printed object. So since this STL files represent the surface using triangular facets, it is crucial that the triangles are oriented correctly. Because if the triangles geometries are not oriented correctly, there will be a error, or we can say there will be a like irregularity in the layer formation. So many CAD softwares they basically have a repairing tools which include automatic error detections, and which rectify the error and try to improve, or try to change it. And these tools can identify common errors like such as non-manifold edge. If there is an intersection between the triangle between two triangles, they will like this many software will detect it, and if it can be like we can change it, or it can be improved, it will be improved automatically. So after this conversion from like solid modeling to the STL file, in third step, basically what it do, uh, the STL file basically, which is been representing the like we can say digital model of an object, is then transferred to the additive manufacturing machine for the fabrication process. So, however, before the part can be built, we have to take a several necessary steps. That is, the STL file can directly send, if we are directly sending an STL file to the additive manufacturing for printing, the process would be simple as if you're not changing anything, the process is direct. If suppose you are sending this STL file directly to the additive manufacturing machine, you just have to just press OK, and your fabrication will start. If you are not changing any uh, like data or any, by default, if you want to keep any data, you don't want to change any data or inputs, you can just print, click on the print button, and you will be able to the process of fabrication will be start. But prior to, like, we should have we should according to the need, there is some steps. Suppose we have to change some data according to our need. So it is essential basically to verify that the digital representation of the part is correct or not. So additive manufacturing software typically includes a visualization tool that allow user to view and manipulate the part digitally. So these steps ensures that the geometry, or we can say dimensions and other specifications, are accurately aligned with the design or not. So in some cases, like STL file may be necessarily before, manipulation of STL file is necessarily before printing. So the task involves like scaling, orientations, step generation. So in the scaling, if suppose we have to adjust the size of the part to meet our requirement, or we have to build more larger, or we have to build smaller, so we can use this scaling tool and we can change the size of the part what we want to make. Second, the orientation. So orientation basically in the part within the build chamber to optimize build quality. That minim with the making we can use a minimum support structure, and to achieve the desired properties. And support structure also we provide, and to provide this, we use support structure basically to provide the stability and prevent any kind of deformation during the printing process. Even especially we are using this support structures are in overhanging, and any integrated features are is there on. And lastly, slicing the slicing the digital model into a thin horizontal layer to generate the tool path instruction for the additive manufacturing machine. And this basically determines that how the build sequence and layer thickness impact the final part quality and printing time. So some of the AM softwares also offer simulation capabilities to predict and optimize the building process. And this includes simulating the depositions of material layer by layer, identifying the potential issues such as collisions, or if there is an overheating, and also optimize these build parameters for like higher efficiency and for to build a very good quality of product. Though this process basically user may interact with the software to make the adjustment and modification, but there should be like we can say we should have a knowledge or judgment that how this is happening, so that the part is prepared adequately for the successful fabrication. The part what we are making is very precise and is very smooth it is making. So after the step three, it is in step four. Basically, we have to set up the machine to prepare for an actual fabrication of the part. So, which involves the configuration of the machine's specific parameters and ensure that the machine is ready to execute the build process. So, at each machine, every additive machine, may have some specific setups configuration that need to be like configured before initiating or building the part what we want. So these parameters basically depends on the machine design or technologies what different machines are using. So if we go for the examples, we have to predefine the feed rate, laser intensity, like chamber temperature, build platform alignment, whether the platform is aligned or not. If the platform is not aligned, or the layer by layer the product will not be made, there will be a gap between the layers, and there will be no smoothness in the part. So some additive manufacturing machines basically are designed to work with only one or two specific material, and may have limited flexibilities in in terms of material variation or build parameters. So it is crucial to ensure that the selected material what we have selected is compatible with the machine specification or it is not. So accordingly only we have to select the printing machines, that whether this machine is compatible with our product or not, and also to streamline the setup, and like minimum there should be a minimum error also. And so the additive manufacturing machines basically allow us to quickly load if there is a machine which have a like predefined parameters for a like specific material or build or some scenario build scenario. So it will help our part to speed up with less number of time, and the fabrication will be very smooth and consistent. So before basically before initiating the building process, we should verify that all the that setup parameters are correctly configured and aligned with the intended specifications. This we have to check during initialization process of building the additive manufacturing machine. So in a, in step in step 5, the additive manufacturing process, the build up phase transition and from manual setup task computer control building phase. So what we do in this, the initial stage of AM process involve like semi automatic tasks and may require significant manual control interaction and decision. So this includes activities such as machine calibration, material loading and setup verifications and all things. So so during this building process of and build up process, all additive manufacturing machine follow some sequence layer controls, height adjustable platform there is there, material deposition is also there, layer cross section formation is also there. So the building process continues until either the entire object is completed or there is no source material remaining. So depending on the factors such as part size, complexity or machine specification, the build time can vary accordingly. So throughout this build up phase, the additive manufacturing machine is under the control of computer software which coordinates the precise execution of any building instructions. So after this process is over, now this fabricated part is removed from the AM machine and undergo necessity cleanup and finishing before our products is ready for use. So despite of being produced by additive manufacturing machine, the parts what we have made require some post processing to achieve like the desired quality and functionality. And these post processing may include removal of supporting structures or surface smoothing or other finishing operations are also there for to finalize the product what we have is made in the 3D printer. So the part basically in the step 6 removal step. So the part must be separated firstly from the build platform on which it is being produced, and depending upon the various different additive manufacturing technology, This may be like detaching the part from the build plate or removing it from the powder bed. Now, care always, like we have to care, take the remove the part with care so that there should be no damage in our parts. So after that is the application step. So in application steps, what we do uh, after post process in application steps, now after removing, after doing polishing and creating our objects by seeing the part which we have made, which is been made from the like 3D printer, now the part is ready to use. But sometime what happens, we have to do an extra work on the part what we have made. There due to some high temperature high one second, like some during the process, like part some small voids or bubble trapped inside them, and these defects basically what it do, it like compromise the structure integrity of the part. And so it is essential to access and mitigate this risk associated with the internal defect to ensure the reliability and performance of the part in their intended applications. So in some cases, like material may not bond, link, or crystallize optimally during the additive manufacturing process. So the result may be weaker material bond, or you can say the reduced mechanical properties or undesirable microstructures are also there. So it is important for us to optimize the process parameters and material selection to promote this proper bonding and like crystallization of achieving desired parts. So additive manufacturing, after completing the 1 to 8 steps, that what we have to do to make to fabricate a part, such as we have to make a CAD file, then we have to convert that CAD file into STL. After STL, we have to transfer this file to the any 3D printer, and with all changing all the parameters, we can get a fabricated part. So there are various classification of additive manufacturing. So it is classified based on the liquid based, powder based, and solid based. So in liquid based, stereolithography or jetting system or direct light processing uh, parts are there. If we classify in terms of powder based, selective laser sintering, 3D dimensional printing, fusion metal deposit system, electron beam melting, selective layer melting, selective mass sintering, high speed sintering, these are the classification according to the powder based. And if we go for the solid based, fuse deposition modeling, FDM, and sheet stacking technology. So these are the various classifications which is based on certain like liquid, powered, and solid for the additive manufacturing. So if we go for stereolithographic, stereolithographic type, so it is a 3D printing process which is focused on precision and ability to produce high accurate parts. So in stereolithographic, what we actually do, we use a laser beam which is employed to solidify the layer of photopolymer resins which we are using here, which we are, resins which we are using in the vat. So this stereolithographic begins with a vat of a photopolymer resin. It is a kind of tank in which the resins is being kept, and a laser beam is directed across the resin surface, and when this beam, like laser beam, follows the instructions which is being set in their memory, so this selectively harden the layer by layer based on the like digital design which they have provided in their memory. So these beam harden layer by layer the resins. So these layer by layer approach basically allow to build the intricate or precise shapes. And If suppose there is a part which is overhung or undercut, it requires certain structures to prevent any kind of sagging or collapse during the printing. So this supports served as a scaffolding to uphold the part's geometry until it's fully formed. However, there is there we have there is a need to manually remove after printing, which we can remove during the post processing requirement. So once the printing is complete, stereolithographic like printer object typically undergo post-processing step in which if there is an extra layer or you can say support or extra like part is out, we can remove it to make it uh, uh, you can say this post-processing cleaning process. It's like which involves the cleaning to remove excess resins or a support structure, so to ensure that the part surface is very much like smooth and free from any imperfections. After that, in this process, basically curing is very much important. Curing means this part basically is exposed to the intense light, so that the resins can get fully hardened, so that hardened to improve its durability. So this process is basically loaded for its high accuracy and excellent surface finish, and which make it ideal for the application requiring for integrated details, shapes, and fine features. However, there is some limitations also. Like during the post processing step, can increase the production time and cost, and there is a potentials like for material to become brittle over the time and impact the parts life cycle. So the second process is it is a powder base, like it is a laser sintering, which can also known as the selective laser sintering or laser melting also. It is a 3D printing process which utilize a powder material. So laser sintering basically involves a laser tracing across a tightly compact powder bed uh, in a build chamber, and the laser selectively heat or sinter the powder material, causing it to fuse together and form a solid layer according to the design which has been provided into their memory. And this layer by layer approach enables the creation of integrated and complex shade. So after each layer is sintered, so the powder bed drop incrementally down to accommodate the next layer. So basically we use roller to smooth the surface of the powder bed before the next layer is applied, so that to ensure that the surface is flat and uniform uh, for the next layer. So laser sintering has some advantage of generating support structure directly within the powder bed during the printing process. So these support structure provides like stability for the overhung, or if we are using there is an undercut in the part. So minimize the need of any additional support material, and simplify the which basically simplify the post processing requirement. So if if we see that laser sintering is basically is used for high temperature to fuse the powder. We use high temperature to fuse the powder material together. So if we in this basically we use high temperature, so consequently we need cooling time. Also the cooling time required is also more, so that the product can get solidified easily. And the second thing is that the porosity, we can say the presence of voids or gap within a part has been challenging in the laser sintering. So this we have this basically many researchers are mitigating this issue and try to like improve the density and structure of the product use is made by using this process. And laser sintering also, it is also, we can say that it is very much versatile, uh, uh, that it has the ability to process both plastic and material and metal materials. And however, in metal sintering, if we go for typically demands is higher compared to the like plastic sintering, because it have a greater energy. It requires like temperature, it requires higher due to the greater energy required to fuse the metal. Now the third process is like a fusion deposition modeling. It's a solid modeling. uh, it basically used in the 3D printing process that has basically now gaining a more popularity since. And this method basically was developed by Stacy in 1990s. So what basically do, it uses the thermoplastic material, and this thermoplastic material extruded layer by layer to build the object. So essentially, in FDM technology, what it do by we basically basically what it do, it melt the thermoplastic material plastically through a heat extruder and deposit it on the on the build platform according to the geometry what is being made. So each layer of this deposit material then harden and bond to the previous layer, and gradually forming a desired object. So we can for if we want to picturize that how does it work, we can imagine like a hot glue gun. So instead of using we can use a glue gun, hot glue gun, in which glue is coming out. We can think that the glue, in terms of glue, we can use a filament, or we can you can use any like PLA material, any plastic filament. So when you squeeze the trigger or of that hot glue gun, so what happens? The heated nozzle melts the filament. In a hot glue gun, there is a nozzle which is getting heated and melt the glue. So in terms of glue, we use a filament like plastic filament. It will melt that filament and and when we like squeeze the trigger, what will happen? Extrude like the filament from the nozzle, and we can move this nozzle in a different direction, and we can make what we want. So this is how actually a 3D printer which is used, which is using these FDM process works. So this process basically is, if we can say, it's a similar to the 3D printer, which operates by using an FDM technology. So in FDM, if in like we can see in a 3D printer, there is a nozzle which act as a uh, hot glue nozzle, which I have said before, and the plastic filament just flow through the pipe, and it just passes over the nozzle, and this nozzle is heated with certain temperature, which plastically what it can melt uh, the filament, and these filament uh, just over the bed of the 3D printer, it's layer by layer, it's makes this melt layer by layer, and this is how the final products mix. So So apart from this, what are the materials basically currently different 3D printer are using? So material like nylon, which is also known as polyamide. So these are basically used by powder-based sintering process, we can selective layer sintering, or in FDM also we are using this nylon or polyamide material. So nylon is basically have high strength, flexibility, and also very much durable, and very much ideal for producing the functional part with the good mechanical property. Naturally, basically, this nylon is coming in white color, but after printing, we can change the color of this, but naturally, it is available in white color. So nylon is also combined with some powder form of aluminium to create a, like we can create a composite which is known as alumide. And why we are using it? Basically, when we make a composite, what it do? It enhance the property and improve the strength and heat resistance. Second material which is being is using nowadays are ABS material, acrylonitrile butadiene styrene. So these basically are also used in FDM machine, FDM 3D printing machine, and it is basically is strong and have high impact plastic resistance, and it is also suitable for robust part if you want to make a very high durable like material part, it is used with a good mechanical property. And this also comes in various color range, so it is very much versatile for using in various applications. Now third is PLA material. This is most widely used material, and it is a polylactic acid, and it is suitable for both resins based process and also stereolithographic SLA process, FDM process. It is used in every 3D printer. So PLA, and why it is so much famous? Because it is a biodegradable like material, and which is very much environmental friendly, and so that and this like characters makes it more popular choice for the manufacturing of any part. And it also offers good dimensional accuracy, and are very much easy to print relative to other material. Since PLA material is not very much durable or flexible like other material like acrylonitrile butadiene styrene, but it still offers like strength for many applications, and it is also suitable for prototyping and for any kind of prototyping, or if you want to make some functional parts, it is used. Also, some like 3D printer uses ceramic materials, and it is basically a relatively new concept in the 3D printer, and but it offers various level of success nowadays. And after printing, like ceramic material, typically what it requires an additional process like glazing and firing, like which is similar to the like traditional process. So this is the post printing process. So post printing process, what we do to increase or enhance the strength and durability, or we can say the aesthetical appearance of our product. Even in biomaterials, like nowadays various research are also exploring actively exploring the potential of 3D printer with the biomaterials in the medical fields, and using aesthetic limbs and all things with the help of this. So biomaterials also using like human tissues. Many ultimate goal, people are thinking to make a like material that can replicate the structure and the function of human tissues and organs. So in food sector also, in food also, like chocolates material, in food material like chocolate is also used to make intricate shapes of chocolate, any designs or shapes from the chocolate. So these are some materials which has been currently used. The main material, and if we go for the manufacturing field, nylon, ABS, and PLA materials are used much. So these are the some advantages of AM. It's allow the creation of the part with a complex geometry without any incurring additional cost related to the complexity, or it provides any a designer, we can say, that with the freedom to create any kind of integrated shapes and customized parts we can easily make. And it eliminates the cost of mold and dies and reduce the like investment and setup cost. It also offers many versatility of material selection, like we can use polymers, metals, ceramics, and very diverse applications we can use it. But we here basically we can use for low volume and customized replacement, low volume production. We can do it here. Now, limitations of AM is that additive manufacturing in the limitation, it is very much limited to the a size, like low volume we can make it. For like large scale, we cannot go for additive manufacturing. This is one of the major limitations of additive manufacturing, the size of the uh, part. If we have a large size of the part, we cannot build with additive manufacturing. So it is basically we have a part size issue. Secondly, uh, certain materials which are non-weldable materials are difficult to weld alloy. In additive manufacturing, it is a challenging to weld different alloys or which are not weldable. And third, certain we can say for while non-bendable and so various applications after we are seeing the advantage, disadvantage. Now these are used in various applications like prototyping and for prototyping and testings of any functional to validate our design for before the mass production. So we can use these 3D printers there, additive manufacturing concepts there, and even various surgical instruments and also for medical modeling also we are using this AM. And even this manufacturing of molds, jigs, and fixtures for rapid prototyping and production in manufacturing process. Here also we are using additive manufacturing process. So it have wider application nowadays, and even repairing or remanufacturing of like we can say a damaged part to increase the lifespan. We nowadays it is being used in aerospace, defense, everywhere now. Additive manufacturing are being used. So these are the some applications like here a bone tumor which is being made with the help of ABS material, and this like skull, human brain skull is also being made with the help of additive manufacturing, and perfume bottles of different kinds. So in we should know that which process is to be used for the part what we want to make, and which material we have to choose according to that. So if we suppose we want to make a part, to make a prototype which is to be uh, used for the testing, so we must know the property of the material what we have to use, and according to that we have to select an appropriate material for that. And following all the 8 steps which I have discussed before, like make a CAD file, convert it into STL, and this STL file is then sent to the 3D printer, and all the parameters which is suitable for our part, we have to change using the software like from the 3D printer software, and we'll build our part of what we want, a desired part what we want, we can build. So this is all about the introduction of additive manufacturing. So this is all from my side. If you have any queries, you may ask.
Hello, 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 hello. Am I audible?
Yes, you are
Yes.
audible.
Hello. Yes, sir. Audible.
Hello. Yeah, yeah. Yes, you're audible.
Sir, I have a doubt regarding that. Can we do the reverse engineering, sir?
Reverse engineering. Yeah, you can do it. Reverse engineering.
Like,
But
can we
if you want to go for a reverse, but if you want to go for a reverse engineering, you should know that which design you have to make, what is the process, how we can. So before knowing all this thing, how you cannot initiate your reverse engineering, but we can go for it.
Okay, sir. Thank you.
Yeah.
Hello, sir. I want
Hello.
to
Yes.
that the handicapped equipments either their entire like are made using by the AM the process of AM.
Your voice is not clear.
Sir, I want to ask that the handicapped that those people who are handicapped have lost a arm or that their
No, no, I'm not able to proper get you. Your voice is not clear to me.
sir now I am audible.
Yeah, now you're audible.
Hello.
Yeah, yeah, yeah. Go on, go on. Now you're audible. You can ask.
Hello.
Yeah, yeah. Hello. Yeah.
If anyone having doubt, please ask from our expert.
Okay, sir. Okay.
Hello, good evening, sir. Am I audible?
Yeah, you're audible. Yeah.
Sir, actually, I'm a PhD scholar from Jagatpur University. So, can you tell me what is the stabilization time of a printer during the printing? Because while printing, the basic time they need for stabilization, like before the getting ready of the printer. Can you tell me the what is the like minimum or general timing of a stabilization time?
It depends. It basically varies from different printer.
Okay.
So if we are used, it varies. This stabilization time basically varies for different printers what you're using. So what kind
Okay.
of printer you're using basically? Yeah,
Sir, I am using a FDM printer.
FDM printer, right?
Yeah.
Yeah. Okay.
That's what I wanted to know, sir. What is the like? Yeah, it depends on different printer, but generally, how much does it depend on the part we are printing, or like it has a basic time maintaining thing?
No, it also no, yeah, it depends on the what are the material you're using as well. Models
Okay,
like
okay,
heating elements, and yeah, it depends on that also. With
okay,
type of material you're using, what are the ambient temperatures? So it depends on the various factor. You cannot rely on the we cannot say that in one factor it depends.
okay.
So
And
calculate
yeah,
accordingly. Yeah.
yeah. Okay. So one more question, sir. Like when we are printing, like as of ABS or PLA or a flexible material such as thermoplastic polyurethane, does the
Yeah.
flow of the extruded material depend? Like as in like
Yeah,
example, if
yes, yes, it will. Yes, it will depend. The flow will depend. If you are using different material, their properties are different. So flow will depend on the temperature as well. At what temperature the nozzle is kept, and
okay,
what you can say that bed temperature and
okay.
this. Yeah, it will.
So
Depends on.
what is the minimum temperature filament can extrude?
It is different for different materials. So
Sir, can you
suppose if
tell
you go
me?
for the if we go for the PLA material, so it is around 200 to 210. If we go for
Okay,
the ABS material, it is 250 to
okay.
260. So it differ from
Yeah, yeah.
different
That's
material.
what I wanted to know. Thank you, thank you, sir. Thank you
Yeah.
very much.
Hello, hello. Am I audible?
Hello. Yeah. Yeah.
Myself and Hemant Shetty. I just want to know what are the different post-processing tools for the finishing operation. As you mentioned, there post-processing is required.
Yeah, there are different tools like we have to make a surface clear now, so we need deburring also of the external surface what after making that part what we have made from the 3D printer. So we need that process to clean up the surface of the part we make.
Are they easily available?
It depends what kind of surfacing what type of surfaces we are doing it. So it depends. Yeah, sometimes it is easily available. Some parts like sanding paper, we can sandpaper. We can use sandpapers to remove the finer parts, finer filament if it is comes out. So we can sandpaper. Sandpapers are easily available. So some are easily available. Some are not. It depends on the complexity of the design what we have actually.
Okay, thank you. Got it, sir. Thank you.
Sir, continuing with the before guest, I want to continue. Sir, while using sandpaper, though we are using like a layer by layer deposition, so it might affect the layers, sir, because sandpaper, though it comes in different grade, but it might affect the layer. So indirectly, it
No,
will.
no, it depends how much denser you're making your your part.
Okay.
So that how much denser you can say how much infill you're using while using the software of 3D printer software.
Yeah, so but
So if
still, if
yeah,
we are using 100% infill density, but still if we
yeah,
rub a sandpaper on the surface
yeah.
of a 3D printed object, like with especially thermoplastic,
So
it
yeah.
will affect the layers, sir, because It might visibly
It
share the.
no, it depends on how much like force or how much you provide. You're applying your force during the rubbing. So it depends on that also. Na? If you go
Okay.
for the lighter, yeah,
Okay. Sir,
it will, but it will not affect more. It will affect, but it will not affect more.
Okay. So one last question want to ask, like while removing the support material, okay, so we have to sink in a sinking tank, like the any support material we are using. So does it affect the mechanical property or the chemical property? Because minimum we are giving it in a 70-degree centigrade hot sinking tank to remove the support material of a thermoplastic, like what we after the final product is printed, and to remove the support material we use we have to sink in a sinking tank. You can say it as a QSR tank. So does it affect the chemical or mechanical property?
No, it will not affect much more
Okay.
because after means this support is basically is used to like if you have an overhung object, so
Yeah,
you
yeah.
are using an additional support, so it
Okay.
will not affect much. You can,
Okay.
because after that you will remove it, you are using the same material only. Or if suppose you are using a different material, if suppose you are using a different material, it
Okay.
will affect, but it will not affect more, because only the layer will be connected, only the you can say one layer will connect with the one or two layers will be connecting with the support what you are giving here, so it will
Okay.
not like,
Okay. Okay.
yeah.
Sir, like it's
or
my
also
personal.
or also one thing, one more I want to add, or also you can while designing anything, making a part, you're giving a tolerance also, so
Okay.
during the machining it will be removed, so it will not affect.
Okay, sir, like from my personal experience, while printing, okay, like many a time the support material get moistured. Okay,
Yeah.
so it will be
Yes.
very hard while printing because it will not adhere in the bed while printing. Sir, do you have any solution that how can we make the material better, like especially the support material better, or how we dehydrate it from, like how we extract the moisture from the support, because each spool comes very costly. Especially, it is very hard to procure again and again in spite of keeping it in a proper zipper bag. So do you have any solution for that, sir? Like what is the like process post processing that we can demoisturize that?
This basically, personally, I haven't tackled this situation, so I would not.
Okay.
I would
Oh, okay, okay,
like
okay, sir.
and able to help you out with this.
Okay, okay, sir. Okay, not a problem. Thank you very much, sir. Thank you.
Thank you. Thank you.
So regarding certificate,
Yeah, yeah.
Kashish, you can
So,
continue from here.
so thank you very much for the sessions, for today's webinar, for your presence. I am very much thankful. So thank you very much. Have a nice day.
Okay, thank you everyone for attending the webinar. So here's an attention everyone, exciting news awaits. So ISIE India has launched new program introducing the electric vehicle program associated with NITK Suratkal. Okay. Through this initiative, NITK is committed to focusing on connected, autonomous, ADAS, and electric vehicle technologies with live lectures and projects. The course duration is of 6 weeks, comprising 4 weeks of live lectures from the faculties of the NITK, followed by a week dedicated to live projects with NITK certification. This program is tailored for both professionals and individuals seeking to enhance their expertise. So don't miss out on this revolution for the electric vehicle. The batch for this program is going to start from the 30th April with limited seats available. The actual fees for this particular program is of 18,500 rupees, but there is a pre-registration discount of 3,500 rupees if you enroll within 24 hours. So grab this opportunity, learners, to upgrade your skills and be part of our future of electric vehicles. Those who are interested, you'll be getting the payment link in the chat box. You can do the directly payment and get an enrollment for this particular program. लिंक भेजा लिंक भेजा So the payment link is shared to the chat box. Those who are interested to get an enrollment kindly go further for the payment link. Or else you have any inquiry for this particular program or you want to know anything else for this program regarding the course, their curriculum. So you will be getting the link for the inquiry.